Hi folks, we're going to take a look at the third additional question on the Unit 6 assignment. And what they give us is a 100 centimeter wire that's to be cut and bent into two shapes. Okay, so the first shape that it needs to be bent into is a square. Okay, and the second one has to be a rectangle whose width is twice the size of its length. Okay, so we'll give a name to the side length here. We'll call this side length X. And then here, if we call this side length Y, the width has to be 2 times Y. Okay, and what they want us to do is they want us to find the minimum possible total area. So let's write a formula for the total area. So the area of the first will just be X squared. And then we'll add to that the area of the second, which will just be Y, the length, times 2Y, the width. Okay, so the function that we have to minimize is this one here, X squared plus 2Y squared. Okay, but as we've seen fairly often now, we have a function given in terms of two variables, and we need to rewrite that in terms of one variable. Okay, so I think a substitution is going to work well here because we know the total perimeter of the two shapes, because that should add up to the 100 that we started with. Okay, so we'll write an expression for the combined perimeter. So the perimeter of the first is just 4 times x. Notice here how I do this work on the side. I don't want to see this work in the body of the solution. Okay, plus the perimeter of the second one, well, we've got 2y for those two sides, and then for these two sides, that's just going to be 4y. Okay, and that has to total up to 100. Okay, so now we'll isolate one of our variables here and then input it into the equation. So here we've got 4x plus 6y is equal to 100. Okay, now I have to isolate either x or y. I'm going to choose to isolate x because, first of all, 100 is perfectly divisible by 4, and then 6 divided by 4 gives us a nice decimal. It's just 1.5, as opposed to 4 over 6, which is 2/3, which can't be written so nicely in decimal form. Okay, so we'll isolate the x. So here we've got 100. Bring that to the other side, minus 6y, divide by 4. Okay, and that can be simplified to 100 over 4, so 25 minus 6 over 4, 1.5y. Okay, and now we'll substitute this variable x for that expression. So the area now is given by 25 minus 1.5y all squared plus 2y squared. Okay, now let's expand this and simplify to get it into standard form. Okay, so here we have to square this binomial, so it's the square of the first, so 625. Okay, and 2 times the first and last, so 25 times 1.5 should be 37.5. So here we've got 37. Let's just check it here. 25 times 1.5. Yep, 37.5. And then, of course, times 2. Okay, so our middle term is going to be 75. So minus 75y. And then the square of the last. So here 1.5 times 1.5 is just 2.25 y squared. And then, of course, we still have the 2y squared from before. Okay, so we'll just write this in another form. We'll get the y squareds together. So we've got 4.25 y squared minus 75y plus 625. Okay, so first of all, we see, as I guess we hoped for, the function for area is a quadratic function, and the leading coefficient is positive, so it makes sense to be talking about a minimum area. Okay, so let's complete the square to do that. So factor out the 4.25 from the first two terms. Okay, so here we're left with y squared minus, and let's do 75 divided by 4.25. Okay, and since this is an application, let me show you that so you can see it. Since it's an application question, I'm perfectly fine with us estimating this. So we'll estimate it to 17.6. Okay, so minus 17.6y. Okay, and then plus 625. So let's continue on completing the square. So y squared minus 2 times, well, 17.64 divided by 2. Okay, 8.8. Okay, and of course we have to add and subtract the square of 8.8. So 8.8 squared minus 8.8 squared. Okay, let's keep going. So first three terms, of course, factor 2y minus 8.8 squared. Okay, and then we still have this minus 8.8 squared plus 625. Okay, now I just want to stop here for a second because let's keep in mind what they're asking us to find. In the question, if you go back and take a look at the question, what they're looking for is just the dimensions of the two shapes. Okay, they don't actually ask for the minimum area. So since I only need the dimensions, I can actually stop here. Could have even stopped one step ahead because I know that this is going to be the y value, which gives a minimum. Okay, I'll actually continue afterwards and solve this here. But just so that you can see that sometimes you just have to stop as soon as you have the information that you know. So let's actually solve the problem from this here. We know that a y of 8.8 will solve the problem. So for the rectangle, okay, we have the dimensions already because we had y and 2y. So we know that that has to be 8.8 centimeters by twice that. Okay, so we had that before, 17.6 centimeters. Okay, now in order to find the value for the square, we can go back and use this expression to find the x value. Okay, so the x value will be 25 minus 1.5 y, so we can put that in, 8.8. Okay, so I use this equation here. So let's calculate that. 25 minus 1.5 times 8.8, which is equal to 11.8. Okay, and so the dimensions of the square would be 11.8 centimeters by 11.8 centimeters. Okay, now in fact I said I'm running out of room on my sheet, so I'm not going to bother continuing on. Now if they did want the minimum area of itself, well, you'd keep going and simplify this expression to get that k value. Okay, so just a recap again, it's a sort of different take on some of the measurement problems we've been doing, but here we were given a particular length and I just followed the instructions to create the two shapes that I needed and then eventually got to my model, which I could then solve. Okay, that's it.